Hello, Mr. Mailer here, your online math teacher, and welcome to my channel. Today we're going to be continuing my video series on TI tips, and in particular looking at how to do one proportion z-test on your TI-84. So if you find this video helpful, consider smash the like button, subscribing, and let's go. So today we're really looking at how can we do a one sample z-test for population proportions. So we're talking about hypothesis testing here. So let's jump into it. Now, if you're going to do this, you need to know a few things first. You need to know what you want your null hypothesis to be. So in this example here, I have my null hypothesis claiming that population proportion is equal to 0.3. You have to know your alternative hypothesis. So I have a one-side alternative hypothesis here where that proportion is greater than 0.3. And I have my sample statistic here, which is p hat, and that is 35 over 100. And you need to know your successes out of the total sample here. Those numbers are important. You can't just have a decimal. We'll enter your calculator. So let's take this information and see how we can use our calculator. So say I want to run a hypothesis test with those numbers. I'm going to go to stat. I'm going to scroll to the right till I get to tests. And then I'm going to scroll down to one prop z-test, which is the fifth option in this tab. So I'll select it, and it's going to prompt a few things. This p naught it's asking for, that is the aimed population proportion in your null hypothesis. So in this one, it is going to be 0.3 for me. Then you have x and n. X and n, you want to look back to your sample statistic. So x is the number of successes, if you will, while n is your sample size. So x will be 35, n will be 100 for me here. So I am going to type 35 in for x and 100 in for n. Then, under this prop row, you need to select what type of hypothesis test you're running. What's your alternative hypothesis? One-sided, two-sided, and how does it relate to your 0.3? So in this case, my alternative hypothesis is claiming that the true population proportion is greater than 0.3. So what we're going to do is we're going to select greater than p naught, because p naught we already said was 0.3. So once I've selected this, I can go down to calculate, hit enter, and it brings up this screen. So again, I can see my alternative hypothesis in this first row. I see my test statistic, which is this z-score here of about 1.09. I see my p-value in this problem is about 0.137. So this is the value I'd be comparing to my significance level. And again, I see my test statistic and my sample size. So I have all this nice information here. If instead of this, you want to visualize it with some of the information, when you go to run your test, so say if we go back to our one prop z test, instead of hitting calculate, if I had selected draw instead, what my calculator would have done is it would bring me to the grapher, but instead of graphing a function, it's going to graph our normal distribution, and it's going to shade in the area in the tail representing the likelihood that we would by chance get a value as extreme or more extreme than what we want. So this is our one-side alternative hypothesis, the area. Again, you can see your p-value down at the bottom, and you can see your test statistic. So both these are great ways to get your information. And the only difference, if you want to run a different type of hypothesis test, maybe you want to do for proportions a two-sided alternative, is you're going to change that option when you run your when you go to stats to run your test. So maybe I'm running a two-sided alternative, so I want not equal to p naught instead. I can either do calculate or draw. I kind of like draw because it gives us that visualization. But again, it'll draw us our normal curve, shading the appropriate areas under the curve. And again, it will give us our test statistic, that z-score, and our p-value. So I hope you found this video helpful. If you did, smash the like button, subscribe, and have an awesome day.